Right. All right, inequalities. So we got math 335. This is review inequalities. We'll start with linear. So let's say our first example is 3x plus 5 is less than or equal to 9. We go ahead and we solve it like it's normal. Like a normal equals sign. This means if we have a line at 4/3, we have a solid dot on it, and we're looking for everything to the left. And in interval notation, it is negative infinity with parentheses to 4/3 in a bracket. That's just a quick reminder because it's Tuesday. I'll give you some guys some problems to work on yourself. Keep in mind that if you multiply or divide by a negative, the inequality has to flip. So let's give you guys one to work with. Give you a few minutes to do it and we'll do it together. When you guys are doing that, I'm gonna go over where we left off last time. Oh, we're doing special cases. No one here, it's a little harder to tell when everyone's ready. Give you guys another minute and we'll do it together.
I'm good.
I'm all good.
I'm good as well.
All right, let's walk through it then. Oh, this is different color or different shapes. We add 3 to both sides and we get negative 4x is greater than 10. And divide by negative 4. And I get x, 10 over negative 4 reduces to negative 5 over 2. And we don't forget to switch the sign. There we go. Thank you. Someone showed up. We use a hollow point when it's just less than, doesn't have an equal sign. We are going to the left again. So you can either do the shading like that or the arrow to the left. And in interval notation, we have the two values that it touches, and then infinities are always parentheses. If it's less than and not less than or equal to, it's also parentheses. All right, any questions? Let's kick it up a notch. Let's try that one.
Just in case you're curious about like who's done or not, I'm done.
Okay,
Me too. I'm done as well.
I'm also done.
all right, that's enough of you. Let's Get moving. Let's move which way you guys want to move the X?
I moved the X to the right side.
So if we do that, we'll have 4x on the right. Did you say move it to the right side? No, I have the feeling that you said the opposite.
Yeah, I had my X's on the right side, but I started off by adding 7. I don't know
Okay.
if it matters, but
Yeah, we want to add 7. So we have 11 is greater than or equal to 4x. So we divide by 4. And we get 11/4 is greater than or equal to x. If we want to switch it around, we get x is less than or equal to 11/4. It's a solid point. All right, so let's give you guys another one. What is this lesson? What's her? Oh, it's just we're reviewing on inequalities.
I'm done with it.
Okay. Couple people in here, so writing at least.
All good.
Okay. All right. So we want to get the x by itself. It's in the middle, so we'll just start clearing stuff away from it. We'll start by subtracting 1. Got -4 is less than 3x is less than or equal to 6. We divide by 3 everywhere. And so we have -4/3 is less than x, which is less than or equal to 2. In terms of notation, going from -4/3 to 2. The 2 gets a bracket. -4/3 gets the curly, the regular parentheses. Hopefully you guys got that. I'm making shit up as I go now. See how this turned out. All right, how you guys doing? You guys add 4x everywhere?
Yeah.
And maybe we'll subtract 10 everywhere too. We got -7 is less than or equal to 4x. Is less than or equal to 4. Divide everywhere by 4. And we get -7/4 is less than or equal to x is less than or equal to 1. Which means we're going to go from -7/4 to 1. And they're both got an equal portion, so we're going to do the brackets. Now. Let's see, let's. Do a quadratic. This will take you a little bit longer. So what does this factor to?
I didn't understand that.
Yeah, I was gonna say that because I did factor it, but I just wanted to make sure I got x minus 2 and x minus 4. I wanted to make sure that I was right with that.
That is correct. So once you factor it like that, that's where we need to do the number line. You set each of these equal to 0, and you're gonna get x equals 2 and x equal, oops. And we're gonna do test regions in there.
So after that, we would just start putting them on the number line.
What? Yeah. So we put them on the note, well, we check regions. So for each region up above, we're gonna, for each number that's green, we're gonna plug it here. We want to see if it's positive or negative. So if I plug in 0, I've got 0 minus 2 and 0 minus 4. This parentheses negative and that parentheses negative, which means this overall region is positive when we multiply them together. If we do the same thing with the 3, we've got 3 minus 2 and 3 minus 4. We've got a positive and a negative, which makes this region negative. And if we stick in 10, 10 minus 2 and 10 minus 4 are both positive. So with that in mind, we now want to go, well, our original thing was greater than 0. Things that are greater than 0 are positive. So we're looking for the 2 positive regions. There is no equal sign, so we have hollow points. And we're doing the region that shades in that positive region. So we're looking at negative infinity to 2 in union with 4 to infinity. Let's do a couple more like that. Let's see, it's negative 13. So what do you guys get when you factor?
When I factored, I got x plus 2 and then x minus 15.
Good. That is the correct factorization. It's easy to look at it and go 10 and 3 because they multiply to 30 and they add to 13, but this being negative screws it up. So you gotta be patient sometimes. So that means if I set these equal to 0, I get critical points of -2 and +15. Now we test it. Let's do like maybe 100 over here, 0, and 100. Let's see, if I do x plus 2 and I do x minus 15, going across the board, what do I get? For x plus 2, if I stick in a -100, this is going to be negative, and that will be negative. So they're both positive, or that makes it positive when we multiply them. If I stick in 0, this is 2 and -15, so positive, negative. That's a negative region. And if I stick in 100, I've got a positive and a positive. So that makes that a positive region. So now we're looking for, got to go up to the original equation, see that we're looking for less than or equal to. So we're going to definitely include these 2 points right here. And less than or equal to is where the value would be negative. And the negative value is in this negative region right here. And if we write it in interval notation, we've got -2 to 15. This is the best way to put it. It's all, you could also put -2 is less than or equal to x is less than or equal to 15. So in the interest of speeding it up, I will have it in the factored form already. Ah. If I have it in a factored form already, I can just give you some crazy shit. Oh, let's make it less than or greater than or equal to. Remember that the parentheses in the bottom also generate critical points. And the bottom can never equal 0. I got carried away. It should be fun. Okay, let's see. Spots where it can equal are at -5/2, 12, and 7. And where it cannot equal is -1 and 15. So. Let's see, -5/2 is the lowest one. And I've got -1, 7, 12, and 15. I'm going to do the 2x plus 5, the x minus 12, x minus 7, x plus 1, x minus 15, kind of in that order. I do want to put circles on them now so that I don't forget. The -1 and the 15 have to be hollow points because of the denominator and they can never equal. And the other ones can be solid points because they're all on top. And so now I'm just going to go through and let's pick some values from each region. Let's go like -100, -2, 0, 10, 13, and 20. And now I'm going to start going. I'm going to start checking them. If I stick in -100 into 2x plus 5, I've got -200 plus 5. That's definitely negative. And so is anything that is subtracting something. -100 minus anything is also all negatives. And that's got a negative, so that's a negative. -100 plus 1 is still going to be negative. It's -99. So I've got 5 negatives, that region is a negative. If I stick in -2, I've got -2 times 2 would be -4, plus 5 is +1. So that's a positive. The negatives are all still negative. And -2 plus 1 is -1, so that's negative. I've got 4 negative signs. This is a positive region. If I stick in 0, I can just use the signs of the things at the end. I've got plus, minus, minus, plus, minus. There's 3 negatives, that region is negative. If I stick in 10, any of them that have a plus are going to be positive. 10 minus 12 is still negative. 10 minus 7 is positive. 10 minus 15 is still negative. So I've got 2 negatives, that makes it positive. If I stick in 13, we still have the same thing with the positives. 2x plus 5 and x plus 1 are both positive. 13 minus 12 is 1, that's positive. 13 minus 7 is 6, that's positive. 13 minus 15 is -2, that's negative. There's only 1 negative sign, so those all multiply to make a negative number. And finally, the last one has all positives when we stick it in. So then we go and we look at the equation and go, what regions were asked for? We were asked for values that were greater than 0. That's going to be right here. And that's going to be right here. And that's going to be right here. So I've got -5/2 to -1. The -5/2 gets a bracket because it's a closed point. The other one's a parentheses because it's hollow. And I've got 2 more regions, so I'm going to have a couple of unions going on here. The next region is 7 to 12. And they're both hard points, hollow or solid points, so they get brackets. And our final region that we're doing is going to be 15 to infinity. Infinity always gets a parentheses, and 15 is hollow, so it gets a bracket like that. If you wanted to think of this in another way, you could say -5/2 is less than equal to x, which is less than -1, or 7 is less than or equal to x is less than or equal to 2, or 15 is less than x is less than infinity. How's that? Was that fun?
A lot of work.
A lot of work, right? On the test, it won't be anything like that, but if you can follow along with what we did here, you'll be fine. A lot of work checking it and being very careful in how we go about doing stuff. Let's throw an absolute value one up real quick before the other class comes in. And so as a reminder, you got to do it two ways. The first way is you drop the absolute value sign, you keep everything the same. And the other one, you drop the absolute value sign, you switch the inequality and you change the value over here. The less than one has an and, less than has an and sound. This can be done as a sandwich. Which means I can put the -7 on the left and put 2x plus 1 between them. And now it's not any different than what we were just doing. The only differences was dealing with the absolute value sign. And it's 3 o'clock, so we'll take a break for 10 minutes until the other class comes in. Or the rest of the class, I should say.